to week 2 of the June workshop series. I am Emily Fuchs, and there are several helpers that will be part of today's workshop and the subsequent workshops next week and the week after. They're listed here. We have Colin, Natasha, Mohammed, Nurukta, and Huijin. So thank you to all the helpers as well. We are the Holland Computing Center, and we provide computing resources to the University of Nebraska system. We're going to be talking in more detail about what resources we provide and how to use specifically the HCC clusters next week. So I'm not going to go into much detail on that unless people have specific questions today. But in short, we provide access to a couple different supercomputing clusters, Crane and Rhino, as well as storage and facilitation services. So just one-on-one helping you use the HCC resources and troubleshooting your codes and helping you figure out the best way to submit your jobs. Okay, this is just an outline of the lessons that we're going to be doing this month, and we're currently on week 2. So that's a continuation of the Bash lessons that we started last week. We didn't quite get through all of them. We usually need a little bit more than a 4-hour chunk to get through all of the Bash lessons. And then once we finished with that, we'll switch gears completely and we'll learn how to use Git, which is a software that's used for managing the versions of your software. So it's a version control software. And we'll get into in an hour or so, once we finish the Bash lessons, we'll talk a little bit about what Git is good for and why it's useful and why everybody should be using it. And what are some of the nice features that it provides. Okay, so we already talked about this last week. We did a brief overview of the Unix shell. So you already probably know a lot of this because you got familiar with it last week, but essentially it's a way of interacting with the operating system. Instead of using a graphical user interface, you just enter commands into the command line on a terminal. And it's just a way of telling the terminal what you want it to do and what program you want it to execute, and giving it the arguments it needs just in a text format from the command line, and instead of clicking on buttons and stuff like that. We're going to be using the Bash shell like we did last week, and we learned many of these already, but in total, what we'll end up learning in this workshop is really just like 10 to 15 basic commands that you can combine in many powerful ways to do a lot of stuff that you wouldn't normally have been able to do so quickly just from the command line. We are still going to be logging into Crane, so hopefully everybody's able to do that. In principle, you can also enter these commands on your laptop as well. Most of them should work if you have a Mac terminal or a Windows version 10 or later. You can use the command prompt to just enter these commands if you have, assuming you have Git installed for the Git lessons. For the Bash lessons, you don't need Git. This is just an overview. Some of these we've learned already. Some of these Bash commands we've already learned. So if you download these slides and just like to have this one as a sort of a cheat sheet, that might be helpful. But you can probably find a lot of even better cheat sheets online if you just Google it. So last week the lessons that we got through were navigating files and directories. So we learned how to use CD to change directory, ls to list what was in our directory, pwd, which is print working directory, to show which directory we were in. We also did the lesson working with files and directories. So we learned how to create new directories with the make dir command. copy files with the CP command, move or rename files and directories with the MV command, remove or delete things using RM, and then open up a simple text editor called Nano. You guys also got through the pipes and filters lesson where we learned about the word count command, WC, how to sort output, and how to select unique lines from output using the unique command. And also how to, I think you guys also learned how to just select the first X number of lines from output using the head command, or from a file using the head command. We learned about piping output from one command into the input of another command using the pipe operator. And then we also, I think, briefly went over the redirection operators, which redirects output from the terminal into a file. So instead of having output appear on the terminal window, it is redirected into a file. You guys talked about loops. So you wrote loops that would iterate over a certain number of items in a list that you provided, and then execute commands that were placed between the do and done keywords. And we're going to do a little bit more with loops today. So that might help refresh your memory a little bit. Today we're going to be talking about shell scripts. So that's basically just, a shell script is essentially just a text file that contains a bunch of shell commands that you can execute the shell script just from the command line with a single line, and then it will just carry out all of the commands in that script. So it's basically just saving a bunch of commands in a file so that you can execute them over and over again and be able to reproduce your work. So it's like a little program. And then after that, we'll talk about finding things. So that refers to being able to search through a file to find a certain piece of text that you want, or being able to find a file in your directory tree. So you may not remember where you saved something in your directory tree and you want to be able to locate it. So that's what we'll be talking about today. I won't talk about Git quite yet. We'll come back to that later. And here's just some links. If you download these slides, these are just some links. Some of them I already put in that first slide, and then a couple of them are just like our website, which contains our documentation and our email in case you have a question for us, and stuff like that. Okay, so are there any questions so far, other than the ones that have been typed into the chat? If not, we'll go ahead and get started. I'm going to switch my share to share my terminal instead of these slides. So let me just do that real quick.
While Emily switches over to her terminal, can we get a quick green check mark in the participants panel or a message to make sure that everyone can sign into the clusters and that they have a GitHub account, please?
Yeah, that's a great idea. The two steps that were needed for the setup for this week are making sure you can log into Crane and then getting your GitHub account, which we won't use until the Git lessons a little bit later. It'll be good to have it ready right now. So if you have not, I still see a lot of people who haven't put the green check marks there by their names. If you have not, then if you have not and you actually need help with it, like you've run into some problem, then put the red no button by your name. Just click on the red no button and then that'll appear by your name and we'll have someone help you. Okay, I'll go ahead and get started. I don't see any red X marks yet, but if one does pop up, then one of the helpers will help you take care of that. Okay, I'm sharing my terminal. How does the size of the font look for everybody? Okay, so we're going to log into Crane. I'm using a demo account. Everyone else will use your username at crane.unl.edu. Password and then your Duo authentication. Okay, so everybody, if you have problems and haven't gotten to this point, you're not logged on, please let us know. So when you're logged in, you should be in your home directory and you should have a few things there if you were at, or a couple things there. If you attended last week's lessons, you will not have that command history file there. You can ignore that. But you should have the data shell directory there. And you might still have the zip file that you unzipped to create the data shell directory. If you do not have that and you need to download it, I'm going to put the command for that in the chat really quick, and then you would just enter this command to download it. Okay. Okay, so you'd first enter that wget command, and then you'd unzip the data shell file that you would end up downloading. Okay. Great. Anybody have trouble with that? Okay, I'm going to start logging my commands, which means they will show up in the command history. So please don't enter this command. This is just something that's going to start the command logging so that you'll be able to see it at that URL. That's just for me. Okay, I'm going to clear my screen now. And get started. So where we left off was at the end of the loops section, and now we are moving on to the shell scripts lesson. So like I said before, if we have a set of commands that we want to run repeatedly, we can essentially just save those commands in a file and tell the shell to execute the commands that's in the file. And this is just what a shell script is. So let's cd into our data shell directory. We actually want to be in the molecules directory. So I'm going to go one level down into molecules. So cd data shell and then cd molecules. Now if you type pwd, you should see your own home directory, not mine, and then data shell molecules. So that's where everybody should be. Now, if we type ls, we can see what's here. So it's essentially a bunch of protein database files, and then some files that we created last week. So yours might look a little bit different from this, depending on what you ended up doing last week. But you should have the cubane, ethane, methane, octane, pentane, and propane.pdb files in this directory. Now, let's say that I wanted to use the head command. I'm going to use head-n15 octane.pdb. So that's going to give me the first 15 lines of the octane.pdb file. And then if you recall from last week, if I put a pipe here, I can pipe that output into another command. So I'm going to pipe it into the tail command, tail-n5. And what tail does is it takes the last 5 lines that you give it. So if I put the first 15 lines of octane.pdb into the tail command and tell it to give me the last 5 lines of that, what I end up with is lines 11 through 15 of octane.pdb, okay? So let's just try that out and press enter. Okay, so that's our output. I want to put that command into a shell script, and I'm going to call it middle.sh. So I'm going to create a new file using nano, and the name of the file is middle.sh. Okay, so that opens a new file called middle.sh. Did everybody get that? So it's just nano space and then middle.sh. And then I'm going to enter my command into that file. So it was head-n15 octane.pdb and then a pipe tail-n5. Okay, so everyone please enter that into that file. I'll just give everyone a second to get it copied down. Okay, I'm going to save it. So I do Control X and it's going to ask me if I want to save it. And I say Y for yes, and then enter to give it that name, middle.sh. Okay, so if I do cat, the cat will show me what's in the file. So I'm going to do cat middle.sh, and it shows me the text that's in that file. Does everybody see that? So if you didn't get it all copied down, you should be able to grab that and put it in that file. Okay, so now I want to run the shell script. So how do I do that? So I need to tell the shell, the bash shell, which program to use to execute it. And the program I want it to use is bash, right? Because it's a shell script that's written using the bash shell language. So I say, I want you to use the bash program to execute the commands in middle.sh. So that's how I execute that script. And I press enter, and that's what I get. So I get the output. The output I got before when I just entered it directly on the command line. Okay, let's make a change to it now. I'm going to open it back up again, nano middle.sh. Just open it up again. And now instead, I want to be able to provide the name of the file on the command line when I run this shell script instead of putting it here hard-coded into the script. So I'm going to replace this octane.pdb with, put it in quotes, $1. And what that is, $1 is a shortcut. And it is what it's replaced with is the first argument on the command line after the name of the script. So when I run this from the command line, I say bash middle.sh, and then I can give it an argument right after that, just a space and then an argument. And that argument is going to be put here where the $1 is, right? So I'm going to provide the name of the PDB file as an argument when I run the script instead of having it here. So let's save this, Control X and Y, and then enter. Okay, now this time it accepts an argument and puts that in the script wherever there's a $1. So bash middle.sh, and then I give it the argument, octane.pdb. So I just put it right here after the name of the script. All right, so I get the same output as before, which is what I expected. But now I can do something different. I can type bash middle.sh contain.pdb. Right, so it's a little bit more flexible now. Um, I can put any file name there. All right, now what if I also want to be able to adjust the range of lines that I print without having to edit the script each time? So instead of doing lines 11 through 15, what if I want to do, lines, 8 through 12 or something like that? So I want to be able to, specify that right here from the command line without editing my script. So to do that, I need to first open up my script and make a few changes. So nano middle.sh. Okay, so now instead of having 15 here, I want it to use a variable that I supply from the command line. And I'm going to use the second argument here. So now instead of just one argument in the command line, I have to provide two. So $1 means the first one, and $2 means the second argument. And I can also replace 5 with $3. So now I need to provide 3 arguments when I call this script. Okay, so let's try that out. I'm going to save this. All right, bash middle.sh. Now let's say I want lines 16 through 20. All right, so 20 gets put into the head command, so that'll give me the first 20 lines, and then 5 will give me the last 5 of those lines. So that will give me lines 16 through 20 of pentane.pdb. All right, does that make sense? Any questions about that so far? Okay, but let's open it up again. If we look at this script, it's a little bit cryptic, right? It's not obvious what it does unless we really look at it closely. So let's go ahead and comment this. So it's a good practice to comment your scripts. So when you look back at them later, you'll remember what they are supposed to do. Everything that starts with this pound sign is a comment, and it will not be executed by the shell. So it will ignore these lines. So I say what this script does and then how to use it. So you use it by, you could also type bash, right? So bash middle.sh, and then the file name is the first argument. The end line is the second argument, and the total number of lines that it prints out is the third argument. Okay, perfect. Was everybody able to do that? And their code worked as expected? So what if we don't know how many input arguments there's going to be? So let's say, for example, I want to give a list of files that all end in .pdb as the arguments for a shell script, but I don't know how many files that is. I don't want to sit there and just count the number of files, or put in $1, $2, $3, $4, up to however many files exist. So what do we do in that case? Let's create a new script. I'm going to call it nano sorted.sh. Okay, so this one, what I want it to do is count the number of lines in all the files that end in .pdb. So WC is word count, and then -L means lines. And star.pdb will give me all the files that end in .pdb that are in my current directory. And then I want to pipe that, and I want to sort that like we did last week. I want to sort it numerically. So sort -n. But this here, I want to supply these lines from the command line. So what I need to do here instead of star.pdb is $1, $2, whoops. Right, but I don't know how many there's going to be ahead of time. So the solution for that is instead of using the 1, 2, 3, etc., the shortcut $sign and then @ symbol here. That's a special variable as well. And what it stands for, what it means is all of the command line arguments. So it will put here a list of all the command line arguments that I enter when I execute this script from the command line. All right, does everybody have that? Let's go ahead and comment it while we're still here. Okay, so this is what it does. It sorts files by length, and then to use it, we type bash sorted.sh and then give it a list of 1 or more file names. Okay, let's close that and see if it works. Okay, bash sorted.sh, and then we can do star.pdb just to give it all the PDB files in the current directory, but we can also add more to this list of files that it counts the lines in. So we could also say, oh, also count the lines in everything in the creatures directory that ends in .dat, right? So the creatures directory is 1 level up from where we are now. So that's why we have to put the .dot. That means go up 1 level and then look in the creatures directory and find everything that ends in .dat. So let's give that list to this sorted.sh script and see what it does. All right, so it found these PDB files and counted the lines, and then it found these creatures files and counted the lines, and then sorted that and printed the output, just as we expected. If anybody had trouble getting their script to do that, please put the red no button by your name. Or just speak up. We can try to help. Okay, so let's do one more example of this. We're going to go to a different directory. We're going to go up 1 level first. So cd space ... And then I want to go into the North Pacific Gyre directory. So you can use tab completion here, so you don't have to type the whole thing out. And then from there, I want to go into the 2012-07-03. So start with the 20 and then enter tab, and it should complete it for you. So that's the directory I want to go into. So if you type pwd, you should be in this directory here. Okay, ls. Okay, so there's a couple shell scripts already in here. One is called goose-stats, and that's just a shell script. It could have been named goose-stats.sh just to give people an idea that it's actually a shell script. That's just by convention, but it doesn't need to end in sh. So what this program does is it just processes a data file, one of these any.txt data files, and then it creates an output file. So the arguments that to run it, you would type bash goose. I'm not going to press enter. I'm just going to show you how you would do this. Bash goose-stats, and then you give it an input file as the argument. So and then you tell it the name of the output file. So stats, I want the output file, let's say, to be named stats, and then the same same name as the input file was. Something like that, right? So you give it an input file name and then an output file for it to create. But I want to have it do this in a loop in a shell script so that I don't have to type this out for every single one. So let's go ahead and create our shell script called do stats, nano do stats.sh. All right, so first we're going to say what this script does in a comment. I'm going to calculate the stats for a set of data files. And we're going to do a loop in here. So it's going to loop over each data file and execute the goostats script and create an output file for that input file. So then we can just pick any name for the name of the input file. I'll just call it data file in. And then we're going to provide a list of input files from the command line. And I don't know how many there are because I didn't count, and I don't want to put, $1, 2, 3, etc. here. That would take forever and be annoying. So I do $@, which means all of our input arguments. Do. And then first I want it to just print out, using the echo command, just print out the name of the data file. And then finally, I want it to do the actual goostats analysis. So data file is the whatever file it's currently on for this iteration. That's the name I want to give it as an input file. And the output file is stats dash and then data file. Does that make sense? Does for loop make sense to people? It's going to loop over all of the input arguments that I give this code. And then for each one, it's going to print the name of that file, that input file, and then it's going to analyze it using the goostats program and create an output file called stats dash and then the original input file name. Okay, so let's save this and exit. All right, let's go ahead and try it out. So bash do stats.sh, and now I need to provide it a list of input files. So I'm going to say, please analyze everything starting with NENE star.txt. And additionally, another interesting or possibly helpful tip is if, for example, you only want to analyze files that end in A or B before the .txt and not these ones that end in Z. You can put in square brackets here, A, B. So that will select anything that starts with NENE, and then the wildcard means anything can be after that, but then it needs to end with either an A or a B .txt. Okay. Now it just loops through each one of those and does the goostats analysis and shows us which one it's on. That's because I included that echo data file line in there. Otherwise, we wouldn't see anything printed to the screen right now. We would just have to wait. But we can kind of see, if we include the echo data file line, we can kind of see how fast it's going. So we can kind of extrapolate and figure out how long we'll have to wait. Okay, it's done. So if I type ls, I see that we have all these output files that it created, stats, dash, and then the original data file name. Did anyone have a problem getting that to work? All right, sometimes we stop here and work on exercises together, but we're probably going to be a little bit low on time for these. So I'm going to just have people, if they would like to work on exercises on their own time after the workshop. I think that's going to be a little bit better use of our time today. So we're going to go ahead and skip exercises, but please ask questions now because we're going to switch to the next lesson, which is finding things. So if you have questions about anything we've done so far, please speak up or enter them in the chat, whatever you're comfortable with. All right, if not, then we'll go ahead and switch gears. We're gonna switch to the finding things lesson, which will teach you how to search for specific text within files, and then later how to find specific files in directories in your directory tree. So we need to go to a different directory for this. CD ... will take us up one level. I think I need to go up one more level. So I'm now in the data shell directory. You know, if you get completely lost, you can always do CD this, and it'll take you, this is short for your home directory, the tilde. And then you can go from there to your data shell directory. So that'll take you where I am now. Right. All right, we want to go into the writing directory. So CD writing and then ls. We see there's a file called haiku.txt there. That's what we're going to use first. Let's go ahead and look at it. We're just going to type cat, which stands for concatenate, and it just prints the contents of a file to the screen. So cat haiku.txt, and then this is what is in that file. We could also, open it with nano to look at it if you want, but sometimes this is fast for short files. Okay, so the tool that we're going to use for searching for text in files, it's a very common one, is called grep, which stands for Global Regular Expression Print. You don't need to remember that, but most people just say grep, and it's kind of a verb. You can grep for something. So let's use that, grep. And then next, the first argument you give it is the string that you want to look for. So I want to look for the word not, N-O-T, in the file haiku.txt. So the first argument is the string I want to look for, and then the second argument is where the file that I want it to search in. Okay, so the output that's printed shows all the complete line that contained that string. So it shows every line that had the word not in it. So by default, the search is not, I'm sorry, by default, the search is case sensitive. So it would not find something with uppercase not. Let's try another one. I'm going to look for the word the with capital T. And the output is these two lines, which contain the word the with a capital T at the beginning. And as you can see, it ignores word boundaries. So this one matched a the that was part of another word. You can have it restrict the match to word boundaries. So let's do it. Let's try it. grep-w. So the -w flag tells it only print results where the match was its own word, right? So not part of another word. Okay, so now we only see this one where the is a separate word. Okay, if we want to search for a string of multiple words, we can use quotes around it.
Excuse me.
Yeah.
Could you please clear up the screen?
Clear the screen. Did you ask to clear the screen?
Yeah, because the command's not in the bottom, so it's up.
Okay, I'm sorry, I can't hear your audio very well.
She is indeed asking for you to clear the screen.
All right, I will do that. Okay. Oh, okay. So if I want to search for two words separated by a space, I'll put that in quotes. So I want to search for the phrase "is not" and obey word boundaries. So I put the -w in there. Okay. So it prints the line "Today it is not working." If I also want it to print the line number where the match was found, I can include -n. So if I look for the word "it," I don't need quotes there. I'm just going to include them anyways. And I want it to print the line number of each match. I include the -n flag, right? So that might be helpful if you want to go to it in the file and edit it or something. I can combine options. So grep -n -w. So this will tell it to obey word boundaries and print the line number as well. If I want it to use to not be case sensitive, I include -i, which stands for, like, I guess, insensitive. Right, so now it shows the with capital as well. Okay, so the one more option I will introduce is -v, and that is a flag that inverts the match, so it prints each line that does not contain a match. So what will this do? Grep -n, so print the line number, -w, obey word boundaries, and -v, invert the match. So it'll print all the lines with line numbers that do not contain the word "the" obeying word boundaries. So the word "the" that's its own word. So none of these lines should contain the word "the" as a word. All right, does that make sense? There's a lot of different things you can do with grep. You can type man grep to show the manual page that gives you a lot of the other options that we won't even be going over today. And then I'm hitting the space bar to go through to page down. And then to quit out of the manual, you type Q. And so if you want to learn more about it, do that. Okay, and then I'm going to do one more example using grep before I move on to searching for files and directories. So the real power of grep comes from using it with complex expressions that they can include wildcards and a lot of other special characters. And these are called regular expressions, which is what the RE stands for in the word grep. Sort of going too far into that is beyond the scope of these lessons. So we'll just do one quick example to show you the sort of thing you can do, and you can learn more about it on your own if you'd like. So let's do an example where we search for the letter O, but we specify that that letter O has to be the second letter. Oops, I did that wrong. Just a sec. I was trying to talk and type at the same time. Okay, so the -E option says it's going to be a regular expression, and then we put quotes around the regular expression. This little up arrow anchors the match to the beginning of the word. So that means whatever matches these two characters has to be at the beginning of the word. The first character is a wildcard. That's kind of like the question mark in Bash, where it can match any character, but just one character, exactly one character. And the O is just a regular O. So what this is saying is, show me all the lines in haiku.txt where O is the second character in that line. The first character can be anything, and the second character has to be O, a lowercase o. Okay, does that sort of make sense? There's a lot of much more powerful things you can do with regular expressions, with a lot more complicated expressions that are very cryptic looking. So if you need to use it, then you will find a way. All right, so that pretty much covers searching for text within files. Other questions about grep? So you might also need to look for a specific file in your directory tree, which can be hard to do if you have a lot of subdirectories and a lot of files. So for this, we're going to use a command called find. So let's go ahead and stay in the current directory that we're in, the writing directory, and type find space and then just a dot. So what this is going to do is find is the program it's going to run, and the first argument is dot, which stands for the current directory, if you recall from yesterday. So it's just a shortcut, which means the current directory that we're in, and that tells find where to look. So it starts in the current directory and it searches recursively down through the directory tree. So it'll search through the current directory for everything that it finds, and then through all of the subdirectories that are contained in the current directory, and some subdirectories of those as well. So let's just see what happens. So we're basically telling it to find everything starting in our current working directory and searching downward. So that's what it gave us. Let's say we only want to look for things that are directories. We don't want it to print out the files. So I type the same thing, find dot and then dash type D, right? There's spaces between all of these arguments, by the way. So type D means type directory instead of file. Okay, so in this case, it only gives us directory names. So we can do the same thing for files. Type F instead of D. Right, so this time it just gave us the file names that it found. Let's say I don't want it to search recursively down through my entire directory tree. In that case, I can give it a max depth option. So max depth 1 means only go down one level, and one level is my current directory. So this will not go any further than my current working directory. So the only file it finds in my current directory is this one. We can also give it min depth option. So find min depth 2. So it won't go, it won't look in my current working directory. It will only look down one level from that and beyond. Right, so it doesn't find haiku.txt anymore, but it finds things below my current working directory in the subdirectories. So I can also search for a particular file name. Let's try this. There's an error with this. There's a problem with this, but let's just try it and see what happens. So it's find dot to start in my current working directory, dash name, and then star.txt. So what I'm trying to do is have it find everything starting in my current directory that ends in .text, but let's see what happens. So instead of finding these other files that obviously also end in .text, it only found haiku.txt. And the reason for that is that it expanded this before it ran the command. So what I was essentially doing was find name haiku.txt. That's what it interpreted this command as doing. But what I want to do is I want to prevent it from expanding the wildcard before using it as an argument in the find command. So I need to put that in quotes. Okay, so this time it did what I expected and wanted it to do. Okay, so find and ls are kind of similar, you may have noticed, but find can be made to search for like much more specific things, and it has more flexibility because it has a lot more options. So how would we combine this with the word count command to find the number of lines in each of the files that I've printed out here? So let's go ahead and try it one way and see if it works. So we're going to try it using a pipe. So we want the output of this piped into the word count command. What I want it to do is count the lines in these files and print it out. All right, so what it did was it just counted the number of files. And that's not what I wanted, right? So instead, what we need to do is this. Okay, so everything in these parentheses with the $sign in front will be executed and interpreted and then used as arguments for the word count command. And that's what we really wanted. So it's a little bit subtle. Here, I'll press enter and we can see the output. So that's what we really wanted it to do. And so the reason is a little bit subtle, and it's because the word count command can accept file name arguments or lines from standard input. And the pipe causes the output from the find command to be read as standard input in the word count command. And in that case, if it's reading it as standard input, it just counts the lines of standard input instead of interpreting them as arguments that it needs to look in that file and count the number of lines in the file. So it's a little bit subtle and confusing, but if it doesn't work with the pipe, try it this way and see if that does what you want it to do. We can use find and grep together. So let's try first grepping for the string capital F, capital E, and where do we want to look for that string? We'll use the find command to specify which files to look in. Okay, so we're saying start one directory up from where we are. That's what ... means. It means go up to the parent directory and start there. And then find everything with a name that ends in .pdb. And then look in those files for the string fe. Okay, and this is the output that we get. Okay, how's everybody doing? We've essentially come to the end of the shell lessons, actually. So yeah, so we've learned how to put our shell commands into a text file that we call a shell script and then execute that from the command line. And then we've learned how to search for text in files using the grep command. And how to search for specific files and directories using the find command. Okay, so I've been asked to explain what this last command does. So everything that's inside these parentheses with the $ in front will be executed and interpreted first. So it's kind of like in math, when you put something inside parentheses, you do that first, right? Just in algebra. So first, find the first argument that you give the find command is where to look. And the ... means the parent directory of the one we're in. So it starts one directory level up from where we are. We're in the writing directory, but it starts one up from there, which is the data shell directory, I think. So it starts there, and it searches downward through the directory tree recursively. And what it searches for is anything with the name given by this -name flag. And then we give it a string that needs to match the name. So it can start with anything, which is given by the wildcard, and then it has to end in .pdb. So find all the files starting one directory level up from where I am now with a name that ends in .pdb. And then the result of the find command is a list of files. It's a list of file names. And that is used as an argument in the grep command. So the grep command says, grep for the string fe, and what files do I search in? Anything that's returned by this file command, or by this find command. So it looks through all the files starting one directory up from where I am that end in .pdb and searches through those files to find the string fe inside of the file. And then what it prints out is just the output from the grep command. So it gives the name of the file and then the line, the entire line where the string fe was found in that file. Does that make sense? Okay, so welcome back, everybody. We're going to be talking about using software called Git for version control of our software projects. So when we use version control to manage our work, the advantages are nothing that's committed to our version control is lost. All of our old revisions of a project, including all the files that we've added to that repository, are saved, unless, of course, we delete all the copies of our repository. There's always a record that's kept of who made what changes and when. So if you're collaborating and working together on a software project with other people in your group or in your department, you will know if there's a change to the code, you'll know who made it, so you know who to ask questions about that change if you need to. You can always revert to a previous version, so it's kind of like having an undo button if you need to. And it makes it very difficult to overwrite or overlook changes that somebody else has made. And we are always alerted when there is a conflict between changes made by two different people on the same project. And we need to manually, in cases like that, we need to manually merge those changes together to make sure that the changes don't conflict with one another and screw everything up. So version control software of one kind or other is used by every large software development project, and even most, if not all, individual programs use it as well, even for doing small projects, because it's just a sane way of keeping track of your work. So in these software carpentry lessons, just a little background, it uses two fictional researchers named Wolfman and Dracula to sort of demonstrate how collaborating using Git works. So this is just a fictional project that they've started that we're using as our example. They're working on plans to send a planetary lander to Mars, and they're just collaborating on the same project, but they don't want to have to send their files back and forth to each other every single time they're updated. So they use Git instead, and they host their repository on a repository hosting service like GitHub to have a central location for it that everybody in their group has access to. So that's how people typically use it. So I'm sharing my screen, which currently has the software carpentry lesson page up here that just has some good little diagrams and helpful graphics that kind of show how Git works. So version control systems like Git save changes sequentially. They save a base document and then they save the changes to the document as they're made so that you don't have multiple entire copies of nearly identical documents saved. So this helps, of course, save space. So two users can start with the same document and make independent changes to that document. And then if the changes don't conflict with one another, they can be automatically merged into one document when they're done. But if they do conflict with one another, the merging process requires one of them, whoever committed their changes last, to confirm that those can be merged and are being merged correctly. So creating a new version of a project is called a commit. So we'll be using that term quite a bit this afternoon. And a complete history of all the commits for a project is known as the repository, which is another word that we'll use a lot. So let's go ahead. We are going to use Git on Crane because it's installed on Crane and it's just a uniform environment for everybody to use so that we don't have issues with Git versions being different and getting errors and things like that. So I'm going to switch over to my terminal again. Okay, so I'm just sharing my whole screen because I might be swishing quite a bit. So does that look okay to everybody, the size and everything of my terminal? Let me know if it doesn't. I'm still logged into Crane and I'm in my home directory. So please go to your home directory on Crane. If you're don't know how to do that, type CD and then just the tilde is a shortcut for your home directory, and that will take you there. And if you type ls, you'll see these the data shell directory there that we were using before. We're not going to be using that directory this time though. Git is essentially just a software package that helps us create repositories for the projects that we have and manage those repositories. And when you use Git for the first time on a new computer, you'll have to configure it a little bit. So we're going to be setting our name, our email, and the text editor we want to use, and a couple of other things using the git config command. So I will go ahead and do that. And you can follow me. Of course, I'll be entering my name and my email, so you want to enter your name and your email. We specify that these are global configs, meaning we want it to be these same configurations to be used for all the projects we use on this machine. And don't worry, every user on Crane has their own configurations. So you're just changing your own Git configurations, not anybody else's. But global just specifies to use the same configurations for all of your own projects. So we do git config -- global user .name and then your name in quotes. Okay, and then give it your email as well, user.email. Okay, so this setting just specifies how we want Git to deal with the, how we want it to recognize and encode the line endings. And this is just the recommended setting for when you're using Bash. So you don't need to probably worry about it too much. Okay, we also are going to specify our editor of choice. You could use a different editor if you want. But for uniformity, since we've been using Nano during these lessons, I'm going to select Nano. And by default, when you create a new repository, the branch that you're using is the master branch, and that's what Git has called it for a long time, but they now are switching over to calling it something different like main. In the software carpentry lessons, it's still called a master branch. So for just continuity, I'm going to keep it as master for these lessons. So you'll need to, if you want to avoid having a warning message when you create a repository, you just need to set your default branch name to master. So that's what we're doing here. If you'd like to use something different like main, you're free to do that. But wherever I type master, you'll want to replace that with main in the following lessons. Okay, has everybody got their settings all done? You can type git config -- list to see a list of all your settings. Okay, so git commands are usually git followed by like a verb, and then the options and arguments that you want to give it. So git config, for example. So you'll see that a lot throughout the remaining lesson. So let's go ahead and just create our first repository though. The first step in creating a repository is creating a directory to store it in. So we're going to call it planets. So make dir is how to create an empty directory. And you want your directory name to be the same as your repository name. So make dir planets. And then we need to cd into that directory, cd planets. It's not a repository yet. Right now it's just an empty directory. In order to create a Git repo from this directory, we need to make sure that we are inside the directory, and then we type git init. That stands for like initialize, I guess. And it says initializing empty Git repository. And then it creates this hidden file called, or hidden directory called .git. It's hidden because it starts with a period. Any directory or file name that starts with a period is hidden, which just means it doesn't show up when you type ls. So ls still shows me nothing, but if I do ls-a for all, show all, then I do see it there, okay? The .git directory is where Git stores information about the project. So don't delete this directory. It will delete all of the project's history on this computer. So, all right, let's just check that everything's set up correctly. I'm going to type git status for it to print out the status of this repo. So it tells us what branch it's on. We're on the master branch. We won't talk about branching because it's beyond the scope of this lesson, but you can create other branches of your repositories for testing out codes and just trying out new things that you don't necessarily want to merge into the main branch, but you want to keep as a separate branch until they're ready. So things like that. We're just going to be working the master branch for today. It says there's no commits yet, which means we haven't created a version of our repo yet. And there's nothing to commit. So it means that it doesn't see anything in this directory that that we might want to add to the repository. We haven't created any files in this directory yet. Okay, so let's go ahead and create our first document in this project. Typically, you'll be adding code and things like that. For today, we're just going to use text files, which is essentially what scripts are. They're basically just text files that are interpreted by an interpreter. So we're just going to create some text files with some notes about Mars and our plans to create our planetary lander. So to create our first file, we use Nano, the Nano editor. And we're going to call this file mars.txt. Okay, so let's open up that file and add some text. So cold and dry, but everything's my favorite color. You can type any text you want. It's not going to change much. Okay, Control X and save. All right, now let's see what happens. If we type ls, we now have a file called mars.txt. If we look at it with the cat command, we see the content is just that one line. And now I type git status, and I see the message says we're on the master branch. There's no commits yet because we haven't committed anything, but it does see that there's some untracked files now. And it suggests that we might want to add those to our to the area where it keeps track of things that we will commit. So it says nothing added to commit, but untracked files are present. Use git add to track them. Okay. All right, so in order to create a new revision of our repository, there's a couple steps. First, we have to add things to what's called the staging area. So we git add mars.txt. So now we're telling it that we want the repository to start tracking changes to this file. And when we're ready and done with all our changes, we will commit them to create a new version of our repo. But we might not quite be ready yet. Maybe we are ready, maybe we're not. But for now, we're just adding it to the staging area. Now, if we type git status, it says, oh, that's a new file called mars.txt that I'm tracking. But it hasn't been committed. It says no commits yet. So the first step is git add, and then the second step is git commit. And then we include a message when we can make a commit that just summarizes the changes we've made. So for this one, we're going to write start notes on Mars as a base. Okay. So now Git takes everything that we told it to save with git add, and it stores a permanent copy or revision in the .git subdirectory. So let's see what happens now if we type git status. So it says now we're on the master branch like before, and there's nothing to commit. The working tree is clean. So it's not noticing any changes that we need to add and commit. So we can use git log to see the project's full history, all of the revisions that were made in reverse chronological order, which means the newest ones are first. And there's only one so far, but for each one, it will show an identifier, the author, and the date, and a message, the message that we typed. Okay, so let's make another change. Let's add another line to mars.txt. The 2 moons may be a problem for Wolfman. Okay. Let's save that and exit. All right, so just like before, it's noticing that there's been modifications to this file, but we haven't added it or committed it yet. Okay, let's say before we actually add and commit those changes, we want to see the difference between what we have in our file and what was last committed. So we can use git diff to show differences. So the output of the git diff command is a little bit cryptic, but what it does is it compares 2 different versions of the file labeled A and B. It gives us a unique computer-generated identifier for each version, And then the minus and plus signs are used to mark the lines that are in one version of the file, but not in the other. So you can see version B contains this line that is not in version A. Okay, so let's try to commit and see what happens. Okay, so I'm gonna git commit with a message, add concerns about effects of Mars moons on Wolfman, and see what happens here. So it gives me basically an error. It says no changes are added to commit. Use git add. So the problem is we tried to commit changes without adding them to the staging area first. So let's do it the right way. Git add mars.txt. And then I can just use the up arrow to go back to that git commit command. And it should work this time. All right, so this time it worked. I can do git log and see the two changes, or git log -- one line, mix them all on one, each one on its own line, and kind of summarizes each revision a little bit more concisely. Okay, so why do we need to do a git add each time before we do a git commit? And the reason is that you might not want to commit everything all at once. So Git uses what's called that staging area to keep track of things that are added to the current change set, but not committed yet. So the analogy that we like to use for this is like mailing a package. So git add is like putting things into the box, and then git commit is like shipping the box. All right, so let's do another example. Okay, I'm going to add another line to this file. But the mummy will appreciate the lack of humidity. Okay, I'm going to save this. And then let's do a git diff. Okay, so it's showing us that the new version of this file it sees in our working directory has a new line in it that does not appear in the version we previously added to the staging area. So let's add it. So git add mars.txt. Okay, now let's do git diff again. So now there's no difference. That's because what we added to the staging area is the same as what it sees in the file. If we wanted to see the difference between the last committed change and what's in the staging area, we do git diff staged. Right? So what we added, the last time we did a commit, there were just 2 lines. But we did add to the staging area with git add, the file version with 3 lines. So that's the difference. Okay, let's go ahead and commit it now. Move it from the staging area to actually shipping off the box with the git commit and saving it as a new version. Okay, so we we do git commit -m, discuss concerns about Mars climate for mummy. Okay, the -m is just our notes to summarize the changes that we made. It stands for message. It's a good idea to have a descriptive message every time you make a revision, so that when someone examines the repository and they see the messages, they'll be able to just quickly glance over and see what was changed. Okay, enter. All right, so let's do git status again, and it shows that we were on the master branch, nothing to commit, working tree is clean. because we just committed all the changes we've made. All right. So to recap a little bit, to make changes to a repository, first we add the files to the staging area, and then we commit the changes. So git add and then git commit. And you can do multiple adds before you commit everything. So you can add a bunch of different files at different times, and then just commit everything all at once with a single commit command. Just like putting a bunch of things in a box and then shipping it off all at once. So I want to quickly go over subdirectories and what happens when you put a subdirectory into a repository. So, so far we've only put a file into this repository, but what if we created a directory inside of it? First of all, generally speaking, you do not need to make your subdirectory into its own Git repository, and you probably don't want to. Although there's some cases where it's good to have nested repositories. In most cases, it's not. So if you created a subdirectory, Git will track the contents of the subdirectory for you. You don't need to make that into its own repo. However, Git does not track the directory itself. It just tracks the files inside of the directory. So let's do an example. I'm going to make a new directory inside of planets called spaceships. And Git status says it's not noticing this empty directory. It's just saying working tree is clean. What if I try to add it? And then it still says the same thing. So it's not really noticing this empty directory. So let's create some files inside of the directory. So the touch command will just create an empty file. I want to create an empty file called Apollo 11 and have it inside the spaceships directory. And then I want to actually create two files at once. So I can do that on one line. Okay, I want to create a file called Sputnik 1 and another one called Apollo 11 and put them both in the spaceships directory. Now if I list what's in there, there are now two new files. So now if I try git status, it sees something and some untracked changes. And if we want to add all of the files in the spaceships directory at once, we can do that. Git add spaceships. Now that there's something in that directory, we can do this. Okay. So now if I type git status, it shows that there's these new files it's tracking, and all we have to do is commit them if we're ready. So I do that with one commit command, git commit -m, add some initial thoughts on spaceships. Okay, so that's how you deal with subdirectories. You need something in the directory or it won't track it, even if it's just an empty file. Okay, I want to actually this time do one or two exercises that I think are helpful for you guys to retain this information. So if you would go to so first of all, you can get there from the workshop website if you have that open. If you click on the Git lesson materials, and then click on creating a repository. I think that's the one we're in. I'm sorry. Tracking changes. And then scroll down. I'm going to have you guys do at least one, if not two, of the exercises here. So scroll down until you find let's go ahead and do committing multiple files. Let's go ahead and do that first, and then we can move on to the next one. So there's a solution there if you need to peek, but please work on it on your own for a few minutes, and then okay, let me give you the link. I'll just put it in the chat. Okay, there's the link. Scroll down to the bottom. It's pretty much all the way at the bottom, and there's an exercise called committing multiple files. So please work on that for a minute or 2 or 3, and then we'll all go over the solution together. Okay, since some people are done, we'll go over the solution to this one together, and whoever's not done can do it along with me. So it says that we need to add some text to mars.txt and then create a new file called venus.txt and add the changes from both files to the staging area and commit those changes. Okay. So nano mars.txt. Can't remember what we're supposed to add. Decision to consider Venus as a base. Okay. So we'll add a line saying we should use Venus as a base. Okay, let's just save and exit that. And then we need to create a new file called Venus. Oops. And add to it some thoughts about Venus as a base. Okay. So we need to add both. We can do it on one line actually, or on 2 separate lines. Okay. So we do a git add mars.txt, venus.txt. And then git commit -m. So we can add 2 different things to the staging area and then commit them all in one step with one message. All right, does that make sense, everybody? It's just good to kind of repeat this several times so you remember the steps. So it might seem repetitive now, but it'll help you remember it later. Let's do one more exercise. We're going to do the biorepository exercise. So it asks us to create a new Git repository. So this is going to be completely separate from the planets project. And we should call it bio. And then we write a 3-line biography of yourself in a file called me.txt, commit the changes, and then we're going to make a modification. We'll modify 1 line in our file and add a 4th line, and then display the differences between the changes we just made and what we committed. Okay. So the key to this one is make sure you don't put this repository inside of your planets repository. So first we're going to cd back to our home directory and create a new repo. So the steps for that are, first we make the directory, make dir bio, cd bio, and git init. Okay, so those are the 3 steps to just creating an empty repository. Make directory, cd into the directory, and then do git init. And then we need to create a file called me.txt. Okay, so I did like my name, where I live, and my favorite color. So you can put anything in there that you want to about yourself. Okay, I'm gonna save that. Now I need to make a new revision in my repo, and the two steps for that are git add me.txt and then git commit with a message, some kind of message about what you did. Okay. All right, now let's make some changes. So it asks us to change one line and add another line. Okay, so I've made a couple changes here. And then instead of adding and committing the changes, the exercise asks us to just show the differences. So we do that with git diff. Okay, so it shows that there's two different versions of this file it's comparing. The one that it's in my working directory that I just changed, and then the one that was last committed with git add. So, or those last put in the staging area with git add. So in version A, it has my name is Emily Fuchs. In version B, it's changed to my name is Emily Dina Fuchs. And then there's a line that exists in version B that does not exist in version A, and that's I work at the Holland Computing Center. Okay, that's it. That was all that the exercise asked us to do. We could also add and commit these changes as well if you wanted to. Should we go ahead and do that? Git add me.txt. All right, does that make sense for everybody? Hopefully nobody accidentally put that in their planets repo. All right, for the next part, we do want to move back to our planets repo. So let's make sure we're in the right directory. I'm going to go up one into the home directory and back down into the planets. Or you could do cd home planets. Okay. Okay, let's go ahead and move on. So the next, are there any questions first? The next exercise is about exploring the history. So we're going to be introducing a new notation to identify the previous revisions of our repository and show how to sort of explore and look at previous revisions. So I'm going to go ahead and clear the screen. Let's do a git log and just kind of see a history of the changes we've made to our planets repo. All right, so you can see each revision has its own unique identifier, and the most recent one is called head, right? The one right before head, shortcut for that is head and then tilde1, and sometimes pronounced head -1. Right, and then the one below that is nicknamed head -2, and so on. So it's just a shorter way than copying down that computer-generated numerical identifier of identifying previous revisions of our repository. So let's use that with git diff to see what happens. Okay, so we're going to do git diff head -1 mars.txt. And it's going to show us the difference between one revision ago and the current version, right? So we just see that the difference is just one line. Similarly, we could do git diff head -2, and the minus is a tilde actually, mars.txt, okay? Oh, so the reason it's only showing this one line is because I also added the Venus file as well. So let's do head -3. There we go. Now we can see 2 lines changed between head -3 and the current version. We could also use that identifier. So we could grab, copy and paste the identifier here and use that instead of head -3. Oh, that's head -2. Here's head -3. Okay. So either way works. What happens though if we want to revert to an older version of our project? So let's say that we accidentally overwrite our original file and mess it up. So let's do that and see what happens. Okay, so I'm gonna just delete some things in here. Control K will delete a whole line. So I'm going to do that. I'm just deleting everything with Control K. Okay, we will need to manufacture our own oxygen. That's what I'm adding to this file and deleting everything else. Okay. You can add something different if you want. Okay, so now if we look in that file, that's what we see, just the one line. Cat mars.txt just shows the one line. Now we do git status, and it says that that file has been modified, of course. I can see that. But let's say that was an accident and I want to go back to the last revision that I stored or that I saved. So I can do that with git checkout head. Head's the last one I saved. Oops, mars.txt. Now be careful. Don't forget the mars.txt, because if you do, you'll get yourself into a little bit of trouble. So git checkout head mars.txt. Now let's see what it says. Cat mars.txt. Okay, so now we're back to the old version. So you could also go to a different version than head. You could do git checkout head -1 using tilde, head tilde1 mars.txt. Okay. Although in this case, I think no, it is one line different. Yeah, so that's one revision ago. So if you do git checkout -- mars.txt, so that will just by default, this is a placeholder, but that will by default revert to the head version. So that's just another way to do it. So that's the same as doing git checkout head mars.txt. So let's go back to our head version. Okay. Is that right? Oh, I guess that was wrong. Sorry about that. So you need to use head. Git checkout head mars.txt. All right. So any questions about that so far? All right. Sometimes in Git repositories, you might want to ignore specific files. So There might, for example, be large data files that you need in the repository for testing things, but you don't want to save changes to them and you don't want to store them as part of the repository. So we can specifically tell Git to ignore things. Let's go ahead and create an empty directory called results. So this is a directory inside of our planets directory, and there's nothing in it yet. Let's create a few empty files and put them in the results file. So actually, we'll create a few in our current directory, in the planets directory. So a dot dot, b dot dot, and then we'll create a few in the results directory. So we're just creating empty files, and we can just give it a list of file names to create empty, to use to create empty files. These two represent data files that are in our planets directory, and then the other two represent output data files in the results directory. So if we do ls, we now see there's new .dat files in our current directory and new .out files in the results directory. If we do git status now, we see that it's showing, it sees these files and asks, tells us that we should track them if we want to track them using git add. But we don't want to. So we are going to specifically create a new hidden file called gitignore or .gitignore. It's hidden because it begins with a dot or a period. And it's a special file name that Git knows is storing all of the files that it should ignore. Okay, so we're going to use nano.gitignore to create this file. And then inside of it, we say anything that begins in, that ends in .dat in the current directory, please ignore. And additionally, ignore everything in the results directory. Okay, so we just put that there in the .gitignore file, and Git will know to ignore that stuff. So I'm going to save it. Now if I do git status, it sees the gitignore file, but it's not showing us these files that it's ignoring anymore. And we do need to add and commit that file. Git add.gitignore, git commit -m, add the ignore file. Okay, everybody get that? Git status now shows that we have a clean working tree. So let's try to add one of the files in the gitignore file. See what happens. So now it says, gives us an error message essentially and tells us if we really want to do it, we can use -f and it'll force it to add it. But otherwise, it's just not going to do it for us. If we want to see the status of all the files, including the ignored files, we do this. Git status -- ignored. Okay, now it will include that in the status output. Okay, everybody comfortable with the gitignore file? If you do ls without the -a, you don't see it here because it's a hidden file. Just like the .git directory in here, it's hidden. If I do -a, we see the git directory and the gitignore file now. Okay, so we've kind of covered everything we're going to cover in terms of working with Git repositories and creating Git repositories on your own computer or on a cluster, for example, as well. So we haven't discussed how to store those repositories remotely on a repository hosting service like GitHub, and that's what we're going to do next. So If you're working in a collaboration, for example, or if you just want to save your project somewhere, have it kind of backed up on a place like GitHub, so you have a place to go if you accidentally delete it off of your computer, then it's a good idea to host it on GitHub. If you're collaborating, especially, you need to host it somewhere like GitHub because your collaborators will need a place to push their changes and to pull down the changes that you've made to the repo. So we'll need a central accessible location for everybody in your collaboration. So if a nice thing about hosting it on GitHub is that if you, like I said, if you accidentally delete your local copy, you can download it or clone it onto your laptop or your desktop. So in order to start doing that, we each need to have an account on github.com. So hopefully that was part of the setup instructions for this workshop. So hopefully everybody's already got that set up. What we're going to do first is put our planets repository onto GitHub. Okay. So please go get a browser and open up the github.com website and log in to your account. So I can sign out. I'm signed in already, but I can sign out, and then you just click sign in and then sign in. And then you can see all of your repositories that you've contributed to and created. I go to my repositories and it lists all the ones that I own. All right, is everybody able to log into GitHub and see their repositories? There might not be any, of course, but we're going to add one today. Okay, so the first step is to create an empty repository with the name planets on GitHub. So that's what we're going to do first. Go ahead to the upper right, there's a little plus icon. If you click on it, there's a selection called New Repository. So click on that and then call it planets, lowercase. All of your repositories on GitHub, if you don't pay for a subscription, all of your repositories are public. So don't put anything here that you wouldn't want anyone to see. And then there's other options, but we're just going to create it without doing any of those things. All right, so what that essentially does on the GitHub server is it does those steps that we did when we created a repository on our laptop. So it did make dir planets, cd planets, and git init. Essentially just creates this empty repository, and there's nothing in there yet. So what we need to do now is connect it to our local repository. So first we copy this URL. So there should be a URL here that begins with HTTPS. You want, if it's this one, this is git at GitHub, then click on HTTPS to get the HTTPS one and just copy that. And then let's go back to our terminal. Okay, so we're still inside the planets directory, which is our local repo. And what we need to do is we need to add the URL for our remote repository. And the command for that is git remote add origin. Origin is just a shortcut for the name of the remote repository. And then paste the URL. So it's git remote add origin and then URL of your repository on GitHub. Okay, to check on that, you can type git remote -v and it will show you the URL. Okay, now the URL is here, but we still haven't put all of the stuff that's in this repo into our remote repo. The remote one on GitHub is still empty. So to populate that with all the history of our repository that we have locally, the command is git push. So we push the changes up to the remote one. Git push origin master. And it's going to ask for my username and password, of course, because not just anyone can make changes to your GitHub repository. Okay. How did that go for everybody? So I see an output here that doesn't include the word error. So hopefully that worked. Let's go up back to GitHub, and if you just click on the word, the repository name in the top left, it should show you all of the files in your repository. And you can see now I have mars.txt, venus.txt, .getignore, and then that spaceships file or directory that I created. And I can even click on that and look inside. Okay, how is everybody doing? No, you don't have to be logged into GitHub while you do this. You need to log in to create that empty planets repo and to copy that URL, but then I can close the browser while I push the changes locally up to GitHub. Yep, and then it just asks for the username and password, so I verify my identity and works. Okay, so you can push changes to the remote repo, but you can also pull changes from the remote to your local version. There haven't been any changes, so if I do that, it won't change anything locally. But the command is git pull origin master. And it just gives me a message saying how to basically how to squelch this message if I want. Don't worry about this for now. We're going to talk about merging changes a little bit later if we get to it. I think we will. Okay. All right. Yeah, so there's a question in the chat. It says that would pull grab other people's changes? Yes, it will grab other people's changes, but only if they've pushed those changes to GitHub. If they've made changes on their local machine without pushing them to GitHub yet, then it won't see those. It'll only see the stuff that's been pushed up to GitHub by my collaborators. Does that answer your question? Let's see, there was a question about two-factor authentication with GitHub, and possibly that's causing the git push origin master command not to work. I am not sure. That might be something. I don't use two-factor yet for my GitHub account. I just haven't implemented it. If anyone else is having the same problem, could you sort of enter that into the chat and just let us know if there's more than one person experiencing that? Or if any of the other helpers that are online have experience using dual factor for their GitHub accounts. All right, so we might have to circle back to that and sort of diagnose that separately or in a breakout room. Let's see, I don't know, maybe let's give it a try. Mohammed, can you switch to a breakout room real quick? and maybe you can help. Okay, just a sec. Okay, we'll go ahead and move on to the next part of the lesson, which is about collaborating. So what I'm going to do next is show how to use GitHub to collaborate on a project where you'll have multiple people working on the same repository at once. Typically, we in the past have had people get into pairs for this exercise, which has advantages and disadvantages. So for today, I'm just going to sort of emulate two different people with my two different terminals being open. And you are free to do the same thing to see what happens when two different people work on the same remote repository and are pushing changes to GitHub simultaneously and see what happens. So we're going to pretend that we're each two different people working on the same repository. So on the left, I'm myself, I'm Emily, and on the right, I'm just going to call this person Jane. So Jane has the yellow terminal, Emily has the white terminal. So first of all, the repository on GitHub is owned by me, it's owned by Emily. So if I want Jane to have access to my GitHub repository, I need to explicitly add her credentials. So I need to go to my GitHub repo on github.com and then go to settings, manage access, and then invite a collaborator, right? And then I will need to enter her name and search for her by either her GitHub username or her full name or her email address that she uses for GitHub. And then she'll get an email, and I think the collaborator has to confirm that through the email that they receive. So once that's been done, both collaborators will have access to making changes to this repository on GitHub. Okay, so I won't do that because there's no real person named Jane. So I will just pretend that I have done that. So okay, so I, as Emily, I'm inside my repository here. I'm in the planets directory, and that's my local copy of the repository. Okay, I'm logged into Crane here as well, so I'm just in my home directory right now. I'm going to create a new temporary directory to put another copy of the planets repo in, a separate copy. Okay, so I'm just going to create a new directory called temp, cd temp, and now I'm going to download the GitHub repository. I'm pretending that I'm Jane, and I'm making a copy of that repo. So the command for that is git clone, and then you grab the URL of the repository, and so it's right here you go to planets, and then click on code, and then make a copy of this URL and put that here, git clone with the URL. Okay. Now anyone can do that because these repositories are public, but not anyone can push changes to that repo on GitHub. Only people given access can do that. Okay. So there's two separate copies of planets in my home directory on Crane. There's one just in my directly inside my home directory, and then there's one inside of a temp directory I created. So now I do cd planets, and if I do pwd now, I see I'm in home and then temp planets. Okay, so these are I'm just emulating two different people working on the same repository. Alrighty, so so as a collaborator, Jane, what I'm going to do is make a change to the repository. So I'm working on this project, and I am going to create a new file inside of the planets directory called Pluto. Nano Pluto.txt. And I'm going to put some text in here. I'm arguing that it is so a planet. And I'm going to save that and add it. Git add Pluto.txt. Now I'm not doing anything to the remote repo on GitHub yet. All I'm doing is working in the local copy that's here in the temp directory I created. Okay, and then I'm going to commit it, but I'm still only committing it to the local copy here in the temp planets directory. I'm still not changing anything on GitHub. Now, let me just check. Remember how I added the URL to the remote repo originally to the local copy I have as the user Emily over here, right? Let's see what it is. If I clone the repo into this other new temp directory, it's automatically set because I cloned it from GitHub. So the location of that remote repository is already there because it was cloned from GitHub. Okay, so I don't have to add the remote, the URL for the remote origin like I did for the other one. All right, so let's. I'm Jane, and I made a change by adding a file called Pluto.txt, and now I want to push that change to GitHub, and the command for that is git push origin master. Okay, and it's going to ask for Jane's URL or Jane's credentials, but I'm actually Emily, so I'm gonna do my credentials. Okay, so if I were Jane, I'd enter Jane's credentials, and GitHub would say, oh, Jane does have access to this this repository, so she can push her changes to it. Okay, so let's go back to the repo itself on GitHub and take a look. And I'm just going to refresh it by clicking on the name of the repo here. And now we see there's a new file called Pluto.txt that says it is a planet. Okay, so that worked. And presumably it would work if I were actually two different people who both had access to this repo. Okay. Now I'm Emily again, and I want to work on it again, and I want to make sure that my copy is up to date with any changes my collaborators have made to the remote repo on GitHub. So if I look now, if I type ls, that Pluto file is not here. It's not in this copy yet. I have to pull that change down from GitHub. So the command for that is git pull origin master. Okay, now if I do ls, I see that there's Pluto.txt, okay? Cat Pluto.txt, it is so a planet. All right, so now I'm up to date with the one on GitHub. So that all worked really well. Everything meshed well. There were no conflicts. When Jane made her change and pushed it to GitHub, and then Emily pulled that change down to her local repo before making any further changes, right? So there were no merged conflicts. So what we're going to talk about next is what do you do if people are making changes at the same time? So what if Jane makes a change, pushes it to GitHub, Emily makes a change and tries to push it up to GitHub before incorporating Jane's changes? Then what happens, right? So that's what we're going to talk about next. But were there any questions over what we just did? So was everybody able to create a separate local copy of the repository, do a git clone, and then make a change and push it to GitHub. That's correct. So the question that just came in the chat is, Jane will not see planets in her GitHub list of repos. That's correct. So it's not owned by her, but she does have access to change it. So if she logs into GitHub and clicks on my repos, my repositories, she will not see it there. I don't know, maybe there's a place to see repositories you have access to, but I can't. I'm not sure. But she, everyone has access. Since these are public, she can go and search for Emily's repositories and see a list of those. Okay, I'm going to pause for just a minute and make sure everybody's on the same page. So just a couple minutes, and then we'll move on to collaborating and merging conflicts, okay? Okay, so what if both collaborators are making changes to the same file at the same time? What happens when they try to push those changes to the remote repo? So we're going to try that next. All right, so I'm going to be Emily this time, and I'm going to, I need to be in my planets repo, and I'm going to, I just did this, so I'll do it again. So git pull origin master to make sure that I'm up to date with the remote version of this repository. And it says that I'm up to date, so that's great. Okay. And then let's do the same for Jane. Okay, she's up to date as well. All right. So Emily, I'm going to make a change to one of the files. So let's see, catmars.txt. Let's see what it looks like. Right now it says 1, 2, 3. There's 4 lines in this file, and Jane should see the same thing. The last line being, we should use Venus as a base. So Emily is going to make a change to that file. I'm going to add a 5th line. I'm going to add a 5th line that says, this line is added to partner, I'll just say Emily, to Emily's copy. All right. And save that. And then I'm going to add it. And commit it. Now, I'm going to push it to the remote copy on GitHub. Okay, great. Now, Jane is going to make some changes as well. But she hasn't pulled the new revisions that were made by Emily yet. So there's going to be a conflict here. So she's going to add a 5th line as well. It's going to be different. We added a different line to Jane's copy. Okay. So let's save that. All right, git add mars.text, git commit, adding a line to Jane's copy. Okay, so we add that, give it a message. Okay, now so far it doesn't give me any errors because all I've done is made a revision to the local copy of the repository. But let's see what happens if I try to push to the remote. Git push origin master, just like before. Okay, so it says it's rejected. Error, failed to push some refs to da 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 da. Okay, so it says we need to, it says usually caused by another repository pushing to the same ref. You may want to first integrate the remote changes, git pull before pushing again. Okay, so we need to manually merge these because the changes conflict with one another. So the first thing we do is pull, git pull origin. Sorry, hold on. Git pull origin master. Okay. It says automatic merge failed. Fix conflicts and then commit the result. Okay, so let's see what happens if we, to fix it, we need to open up the file and fix it. nanomers.txt. Okay, so it's showing us that there's two different lines that were added to the two different copies, and we need to decide what we want to do there. So I'm going to say, oh, I think I definitely want to delete these. Yeah, so it does edit the file. So we want to delete the stuff that get added and decide which line is better, or maybe we want to keep both lines. Oh yeah, both lines work and don't break the code, so let's keep both of them. And save it. Okay, git add mars.txt. Git commit -m. Merging changes from GitHub. Now let's try to push and see if we get an error this time. Yay. So we'll go back here to the planets repo and let's take a look at the mars.txt file. And it looks like the two lines were both added just like Jane specified when she manually merged them. Yeah, so when you do the git push origin master, so someone just asked in the chat if editing GitHub files depends on Wi-Fi, right? So yes, for sure. I mean, it's sending it to the server. When you do git push origin master, you're sending it to the GitHub server. That's where you're sending your changes. So yes, it uses that URL that is that you added, the remote URL, and it sends those changes to GitHub. But you don't have to have this window open. I'm just keeping it open so I can check from time to time to show you guys that the changes were made on the GitHub site. All right, so partner A, well, I was calling this person partner A, it's Emily. So Emily's going to now pull the changes. Git pull origin master. And now let's look at mars.txt. Right, so now we see the two lines added by Emily and Jane are there. And both of their copies are up to date with one another. Okay, that actually concludes the lessons for today.